Hi, I'm Patrick. I'm the Applications Engineering Team Lead at Copper Mountain Technologies. Today I'll be demonstrating the OTA antenna test system. So the OTA antenna system is a partner product with Millibox Systems, Copper Mountain, and the extenders will be from Aravan. So inside the chamber, we have the receiving antenna, we have the gimbal, and the DUT antenna will be mounted onto this gimbal. So the antennas from Aravan, these are the TX and RX antennas, so the signal only goes one way. And the DUT we'll be using today is a pair of Aravan WR6 horn antennas, and the VNA will be the Cobalt C4209. So now I'm going to launch the Millibox software. So Millibox provides the software, and the software is completely in Python. So the first step after we started Millibox software would be to align the gimbal. So there's a laser on the gimbal, and then there's a laser target on the receiver antenna. So our goal will be to point that cross right into the receiver cross. So you can see now it's slightly misaligned. I'm going to use the arrow keys to align it. So this step is too big. Press A to reduce the step. Still too big. All right, now I have the horizontal cross aligned, and then I'll go to the vertical cross. Okay, so now the cross is right in the center of the receiving antenna. So now this is when I save the home position. So press 0, set as new home, yes. Now the home position is saved in the Millibox software. And then the next step you always want to do is to press D to do a default sweep, spacebar to start. And now this is when you check all the cable connections and make sure at the extreme angles nothing will break. All right, so now the default sweep just finished, and then we're looking at a figure. This is a simulated result. This process is to make sure the physical arrangement is fine. Now this is when we set up the VNA connection to the Millibox software. So open the Copper Mountain VNA software. Then this is already connected to the VNA there. So I'm going to set up the socket connection. Go to System, Miscellaneous Setup, Network Remote Control Settings. So by default, this will be off. Now turn on the socket server. And then we're using socket port 5025. So go back to the Millibox software and click Y. And we're setting up for VNA. We're using manual entry. So 2. The visa address for this would be TCP IP 0. Okay, so now the Millibox software is connected to the VNA software, and now I will calibrate VNA. I go to calibration menu and calibrate. I'll do a response through calibration. Because we're using the TX-RX version of the Aravan extender, we can only do one direction. And in this case, based on the setup we have to do S12. So with the gimbal pointing right at the receiver antenna, I'm going to hit through and apply. So now I just normalized my S12 to 0 at this position. Now I go back to Millibox software, and Today we'll demonstrate the 1D sweep to see it matches the simulation result from Aerovent's datasheet. So press 1, vertical sweep, horizontal angle will be 0. We'll do from negative 50 degrees to positive 50 degrees and a step size of 1 degree. You can name your file, but I'll just enter. You get to choose a frequency to plot. So I'll choose 140 gigahertz. Press spacebar to start. So now the gimbal will be making measurements. So now it's sweeping vertically from negative 50 degrees to positive 50 degrees. And right during it's doing that, it will show me, keep updating this interactive plot. And I'll bring up the datasheet that we're looking at. So we'll be comparing with the E-plane plot here. So it should be the blue trace. And let's see how it turns out. Now the measurement has finished, and we're looking at this plot at 140 gigahertz. It matches pretty well with the datasheet, which is a simulated response of this antenna. So it is similar but not completely the same, probably because I didn't close the lid for the demonstration purposes. If you are doing a real measurement, you should close the lids like this, and these absorber materials should provide a better than 50 dB absorption for frequencies all the way up to 100 gigahertz. For this system, we don't need a metal cage for this chamber. You can see this is made out of PVC and wood. This is because above 18 gigahertz, where this chamber is designed to work for, there's not really much radiation in the air, so we don't need a Faraday cage to block that signal. All this absorber is doing is to absorb the internal reflection in this chamber. And you'll see we have an absorber here, right around the receiving antenna too. And then if you close the lid, it's going to be completely sealed. So that is the plot we get at 140 gigahertz. And we close the plot. So the Millibox software automatically saves data into CSV files. So if you go to the directory of Millibox, then there's a folder called Millibox plot data. Then you'll see this is the newest file that we just did. And if you open that, this first column would be the angles, and then this row will be the frequency. Today I just demonstrated the OTA antenna test system with Copper Mountain Technologies. For more questions, please reach out to us at coppermountaintech.com, and thank you for watching.